All right, buckle up, everybody, because today we're diving deep into the world of Demis Hassabis.
Yeah, this is going to be a good one.
This isn't just another AI episode, folks.
No.
We're going way beyond the headlines, way beyond the buzzwords like Gemini, to understand what really drives this guy.
I think the real story here, the thing that I'm most fascinated by, is this. How is he using AI to revolutionize medicine?
That's right, and to get the full picture, we've gathered up a whole stack of stuff.
Oh, yeah.
Interviews, keynotes, even podcast snippets.
Wow.
It's like a backstage pass to the cutting edge of AI and its impact on, well, all of us, really.
I mean, you really got to start with DeepMind's AlphaGo. Remember that?
Oh, yeah.
2016, AlphaGo beats a Go champion, and everybody's freaking out.
Watershed moment, right?
Totally. And it was Demis Hassabis leading the charge.
It was huge EE.
Yeah.
I remember thinking, okay, AI has officially arrived. But here's the thing. Hassabis wasn't content with just winning games.
Right.
He saw them as a training ground, a way to build systems that could learn anything.
He really did.
Anything.
He actually said, and I quote, "Step 1, solve intelligence. Step 2, use it to solve everything else."
I mean, imagine trying to pitch that just a few years earlier.
Oh, man, you'd get laughed out of the room.
People thought he was crazy.
The audacity is pretty remarkable.
It is. But you know what? That audacity led to some mind-blowing results.
Like
AlphaFold,
oh, yeah, AlphaFold.
an AI that predicts protein structures.
Nobel Prize in Chemistry.
This wasn't just another tech demo. This was a Nobel Prize.
You know, it's really rare for an AI achievement to be recognized at that level.
Yeah.
And I think what impressed the committee the most was that AlphaFold wasn't just solving a theoretical problem. It had immediate real-world implications for medicine.
Yeah. Okay. So for those of us who aren't, biochem whizzes,
Sure.
can you break down why predicting protein structures is such a big deal?
Well, I think the best way to think about it is this.
Okay.
Proteins are like tiny little machines, and they carry out all the essential functions in our bodies.
Okay.
And understanding their 3D structure is absolutely crucial for developing new drugs,
Okay.
treating diseases, and even unlocking the secrets of how life began.
So it's like having a blueprint for the building blocks of life itself.
Exactly. For decades, scientists have been painstakingly trying to determine protein structures through experiments. But AlphaFold can now predict them with remarkable accuracy,
Really?
just using the protein's genetic code.
Wow, that's amazing. And there's this really cool detail about how AlphaFold actually learns.
Oh, yeah.
It uses this method called intent learning.
Intent learning.
It's like learning to draw a portrait by starting with basic shapes and gradually adding more and more detail.
Interesting.
So AlphaFold starts by focusing on small segments of the protein,
Right, yeah.
predicts their local structures,
Okay.
and then it gradually expands its knowledge to encompass the entire 3D form.
That's a great analogy.
And what's fascinating is that this approach of starting small and building up reflects Hassabis's overall philosophy.
Yeah.
It's not about creating specialized AI. It's about developing systems that can learn and generalize across different domains.
Right, just like AlphaZero.
Oh, yeah.
Mastered chess, Go, and Shogi, all by playing against itself, constantly refining its strategies.
No specific rules programmed for each game.
Nope. It just learns the underlying principles of strategic thinking.
Fascinating.
It is. And that's the amazing thing about Hassabis's work. It's not just about winning or solving puzzles. It's about unlocking this power of general intelligence.
You mean artificial intelligence that can learn and adapt like we do?
Yeah, like the human mind.
Okay, but how do we get from playing games to, revolutionizing medicine? How does all this connect to improving our health and well-being?
Well, that's where things get really exciting,
Okay.
Hassabis believes we're on the edge of a new era. He calls it digital biology.
Digital biology, yeah.
Yeah, where AI transforms how we understand and interact with life itself.
It sounds a little sci-fi, but also incredibly promising.
It is. It is.
So what does it actually entail? What can we expect to see in this digital biology world?
Well, think about it. We've got AlphaFold, right? Cracked the code of protein structures. Now imagine taking that a step further.
Okay.
Simulating entire cells, maybe even organs, all in a computer.
Whoa, hold on. Simulating a whole heart or a brain.
Yeah.
How is that even possible?
I know, it sounds like something straight out of a movie, right?
Totally.
But with these advancements in computational power and AI algorithms, it's becoming more and more realistic.
I mean, I guess what seemed impossible a few years ago is now pretty normal in the AI world, right?
Exactly.
Okay, but let's say we can do it.
Yeah.
What's the point of having these virtual cells and organs? What practical benefits would it bring?
Well, imagine a world where we could test new drugs and therapies on virtual organs instead of relying on those lengthy and expensive clinical trials.
Okay.
We could speed up the drug discovery process, like exponentially.
So instead of waiting years for a new drug, we could potentially see breakthroughs in months or even weeks.
Yeah, exactly.
Wow.
And it goes way beyond just speed. We could use these simulations to personalize medicine, tailoring treatments to each person's unique biology.
Personalized medicine, huh? That's been a buzzword for a while, but it feels like we're finally getting to a point where it could be real.
We are.
What would that look like for, say, someone with a chronic illness?
Well, imagine having a digital twin, a virtual model of your own body. Doctors could use it to simulate how you'd respond to different treatments.
Wow.
They could identify the most effective drugs with the fewest side effects, all tailored to your specific genetic makeup and medical history.
It's like having a personalized health advisor powered by AI.
Isn't that amazing?
That's pretty incredible.
And it doesn't stop there. Simulating biological systems could also help us understand the fundamental processes of life. We could see breakthroughs in things like regenerative medicine, maybe even tackling those age-related diseases.
We're talking extending lifespan, reversing aging, maybe even regrowing damaged organs.
It's all on the table. We're talking about rewriting the rules of biology and medicine using AI as the ultimate tool.
Okay, but all this sounds incredibly complex and expensive.
Right.
Is this only going to be available to, like, a select few?
That's a valid concern, and it's something Hassabis himself has talked about a lot. He's a big advocate for making sure these AI benefits are accessible to everyone, not just a privileged few.
So it's not just about the breakthroughs themselves. It's about making sure those breakthroughs benefit humanity as a whole.
Exactly. Democratizing access to healthcare.
Right.
Using AI to level the playing field, make sure everyone has a chance to live longer, healthier lives.
But even with the best intentions, there are always potential risks with technology this powerful. How can we be sure these tools are used responsibly and ethically?
That's where the conversation gets really interesting, and it's something Demis Hassabis has been thinking about deeply right from the start.
Okay, so let's get into that. What are some of the ethical challenges and potential pitfalls we need to be aware of as we move into this new world of digital biology?
Well, data privacy is a big one. If we're talking about creating digital twins, that means gathering and analyzing tons of personal health data.
Right.
Protecting that data and making sure it's not misused is absolutely crucial.
Absolutely. It's not just about protecting people's privacy. It's about preventing discrimination based on someone's genetic information. We don't want a world where people are judged or denied opportunities because of their digital twin.
Right. We have to think about the potential for unintended consequences.
Yeah.
Even with the best intentions, we can't always predict how these technologies will be used or how they might change society.
It's like opening Pandora's box. We're unleashing these incredibly powerful tools, and we need to be ready for the good and the bad.
Exactly. And that's why it's so important to have these conversations now, before these technologies are everywhere and it's too late to deal with the ethical side of things.
So it's not just about the science. It's about the ethics, the societal impact, the philosophical questions that come up when we start blurring the lines between the real and the virtual, between the biological and the digital.
And it's about making sure these powerful tools are used to benefit humanity, to create a healthier, more equitable world for everyone. It really is a fascinating paradox when you think about it, right?
Yeah.
Using AI to unlock the secrets of biology, of life itself.
Makes you wonder where the limits of AI really are.
It does, doesn't it?
It's like we're entering this whole new dimension of scientific exploration, and AI is the key.
And Demis Hassabis, he really seems to be at the forefront of that.
Yeah.
Pushing the boundaries of what's possible.
He's definitely got a knack for tackling these big, grand challenges.
Yeah.
From mastering games to predicting protein structures. But what's next for him?
What's the next big leap forward?
Yeah.
Well, you might have heard of Gato and Gemini.
Gato, yeah, that rings a bell.
Yeah.
Wasn't that described as like a general-purpose AI?
That's right. Unlike AlphaFold, which is very specific to protein folding, Gato is designed to do a whole bunch of different things. Play games, control robots, even translate languages.
So it's like a Swiss Army knife of AI.
Exactly. It can adapt to all these different situations and challenges.
Oh, wow.
And it all goes back to Hassabis's vision of creating artificial general intelligence, AI that can learn and problem solve across different areas, just like we do.
That's fascinating. Okay, what about Gemini? Where does that fit in?
Well, Gemini's even more ambitious.
Okay.
It's supposed to be the next generation of large language models, building on what things like ChatGPT can do, but even better.
So AI that can understand and generate human language even more smoothly and accurately.
Yes, but it goes beyond just language. Gemini is designed to integrate different modalities, combining language with images, videos, even actions.
So it's like taking the power of those language models and giving them the ability to interact with the world in a much richer way.
Precisely. And this could have huge implications for just about everything, from how we do scientific research to how we interact with technology every day.
Imagine an AI assistant that not only understands what you say, but can also interpret your visual cues and even anticipate what you need.
Or an AI that can work with scientists to design experiments, analyze data, maybe even come up with new hypotheses.
That's pretty mind-boggling.
It is, isn't it? And that's what makes Demis Hassabis so fascinating. He's not just building AI systems, he's reimagining what's even possible.
Yeah.
He's asking those really big questions about the nature of intelligence, the future of humanity, our place in the universe.
He's a big thinker, that's for sure.
Yeah.
And he's got the talent and the resources to turn those big thoughts into reality.
He does.
Well, as we wrap up this deep dive, I think it's safe to say Demis Hassabis is a force to be reckoned with. From revolutionizing gaming to pushing the limits of medical discovery, he's really leaving his mark.
He is. And his journey's not over yet. With projects like Gato and Gemini on the horizon, who knows what breakthroughs are still to come?
It's an exciting time to be alive, witnessing the dawn of this new era of intelligence.
It really is. And with that, we'll leave you with this thought. If AI can figure out protein folding, if it can help us understand how life began, what other seemingly impossible problems can it solve?
What other wonders are out there waiting to be discovered?
That's something for you to think about.